Class 11 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 3 Coordinate Geometry. Topic Straight Lines. Subtopic General equation of first degree in two variables represents a straight line. Reduction of the general equation of a line to different forms. Distance of a point from a line. Exercise 10.3. General equation of a line. The general equation of first degree in two variables x and y is ax plus by plus c equal to 0, where a, b, c are constants, are reals, and a and b are not zero simultaneously, represents a straight line. Reduce ax plus by plus c equal to 0 to the form number 1 slope intercept form, b intercept form, c Norman form. We have to reduce this general equation of straight line in the following different three forms. Slope intercept form. If b does not equal to 0, then ax plus by plus c equal to 0 can be written as y equal to minus a by b times of x minus c by b. This is the slope intercept form of the line whose slope is minus coefficient of x, that is minus a by b, and y intercept is length of y intercept is this constant minus c by b, which is in the form of what? Which is in the form of y equal to mx plus c. In this form m is called slope and c is called y-intercept. Comparing this equation with this, m equal to intercept of this straight line is minus a by b, and this c equal to minus c by b. If b is 0, then x equal to minus c by a. If b is 0, then x equal to minus c by a, which is a vertical line whose slope is undefined and x-intercept is minus c by a. If b is 0, then the equation of this line will be, this is vertical line whose slope is undefined and x-intercept is, vertical line means this line or this line or this line, so on. Vertical line whose inclination is 90 degree, tangent of 90 degree is undefined, whose slope is undefined. This is suppose y, this is x. If b is 0, then x equal to minus c by a, which is a vertical line which lie on the right or on the left according as minus c by a is plus or minus, and x-intercept is minus c by a. Intercept form. Which form is known as intercept form? Intercept form is x by a plus y by b equal to 1. This form is known as intercept form of straight line. Intercept form straight line. If c does not equal to 0, the constant does not equal to 0, then ax plus by plus c equal to 0 can be written as, if c is transferred on the left side and divide on both sides, after transferring divide on both sides by minus c, we get right side is 1, left side is x by of minus c by a, and y plus y by of something minus c by b, which is in the form of this is in the form of x by a plus y by b equal to 1. This is the intercept form of the equation of a line whose x-intercept is the value small a is minus c by a. The value of minus b is called y-intercept, whose value is minus c by b. Norman form. Let x cos omega plus y sin omega equal to small p B. The normal form of the line represented by the equation ax plus by plus c equal to 0, or this can be written as ax plus by equal to minus c. Thus, both the equations are same, and comparing we get this equation with this equation, they two are same, and comparing coefficients, coefficient of x in here is a, and coefficient of x is cos omega, coefficient of y is b, and coefficient of y is sine omega, and the constant term is minus c divided by small p, which gives first member equal to second member, gives cos omega equal to minus ap by c, and b by sine omega equal to minus c by p gives sine omega is equal to minus b p by 6. A, c, b are constants, but p is not known. Now sine square omega plus cos square omega, whose value is this, whose value is this, and which is equal to 1, from which we have to solve p. From this equation we have to solve, from which we have to solve, from this equation we have to solve p. That is small p is plus minus c by square root of a square plus b square. Put this value in this, we get sine cos omega and sine omega in terms of abc. Therefore cos omega, put the value of p here, we get cos omega is plus minus a by k, and sine omega is plus minus b by k, where k is equal to square root of a square plus b square. Thus, the normal form of the general form is x cos omega plus y sine omega equal to p, where cos omega is equal to this, and sine omega is also equal to this, and small p is equal to this, where k is equal to square root of a square plus b square. That is, cos omega, sine omega, p are expressed in terms of a, b, c respectively. Therefore, their values are known. Proper choice of signs is made so that p should be positive. We have to take proper sign because p should be positive. Distance of a point from a line. Distance of a point from a line. Suppose this is a straight line whose equation is ax plus by plus c equal to 0, and p whose coordinates are x1, y1. We have to find out its perpendicular distance. Suppose pn, the foot is n, this perpendicular. For finding this perpendicular, the distance of a line this from a point x1, y1 is this modulus of this divided by square root of a square plus b square. Originate x is replaced by x1, originate y is replaced by y1 plus c, whose modulus divided by this, so that the distance is positive. Exercise 10.3. Reduce the following equations into slope-intercept form and find their slopes and the y-intercepts. For first, Roman number 1, we have to solve y in terms of, we have to express y in terms of x. This is the required slope-intercept form. Also, its slope is coefficient of x, that is minus 1 by 7. It should be 7. It should be 7. And length of y-intercept is constant, equal to 0. For equation 2, 6x plus 3y minus 5 equal to 0. Solve y in terms of x, which is of the form y equal to mx plus c. M is called slope and c is called intercept. This is the required slope-intercept form. Also, its slope is coefficient of x is minus 2, and length of y-intercept is 5 by 3. For Roman number 3, y equal to 0, which can be written as y equal to 0x plus 0. This is the required slope-intercept form, whose slope, also its slope is 0, and y-intercept is also 0. Question number 2. Reduce the following equations into intercept form and find their intercepts on the axis. Which form is known as the intercept form? X by a plus y by b equal to 1 is called intercept form, where a and b are real numbers, not 0. They are length of intercepts on the respective axes. Let us see. If this equation is x by plus y by b equal to 1, a is the distance of this and b is distance of this. A, b may be either negative or positive. We have this Roman number 1. Transfer 12 on the right side and divide both sides by 12. We get this. This is the required intercept form whose intercepts on the axis are 4 and 6 respectively. For Roman number 2, 4x minus 3y equal to 6. Divide on both sides 6 and put in the standard form, that is x by 3 by 2 and plus y by minus 2 equal to 1. This is the required intercept form whose intercepts on the axis are 3 by 2 and minus 2. For Roman number 3, thrice y plus 2 equal to 0. We get this and put in the standard form, x by 0 plus y by minus 2 by 3 equal to 1. Here a length of intercepts on the axis is 0 and length of intercepts on the y-axis is minus 2 by 3. Intercepts on the axis. Question 3. Reduce the following equations into Norman form. Find their perpendicular distances from the origin and angle between perpendicular and the positive x-axis. For Roman number 1. The equation can be written as this. Constant I asi positive oina thamaga atay sing asina negative coefficient or positive I si lengdana thamasi sign change tawdanaba. Dividing by root over of x ki coefficient minus 1 square plus y ki coefficient root 2 whole square, that is square root of 1 plus 3, that is 2. We get above equation becomes this. Minus half cos of which angle gives minus half, sine of which angle gives root 3 by 2. We have cos 120 gives minus half, sine of 120 gives root 3 by 2. This is the required Norman form and p small p equal to 4 and alpha is 120 degree. For Roman number 2, y minus 2 equal to 0, y equal to 2, which can be written as this, which is equal to x cos of 90 degree plus y sine of 90 degree equal to 2. This is the required Norman form with alpha is 90 degree and p is 2. Roman number 3, x minus y equal to 4, dividing both sides by root over 2, that is square root of 1 square plus minus 1 square root over 2 need to root over 2 na loina yela se. Cos of which angle gives 1 by root 2, sine of which angle gives minus 1 by root 2, that is 315 oirani. X cos of 315 degree plus y sine of 315 degree equal to 2 root 2. This is the required Norman form with alpha is 315 degree and p is 2 root 2. Question number 4. Find the distance of the point this from this line. We have to find out perpendicular distance of this point from this line. The equation of the line is this. We have to put in the standard form by transferring. We get this. The distance of the point minus 1 1 from the line is modulus of when x is replaced by minus 1, y is also replaced by 1, others remains unchanged, whose modulus divided by square root of 12 square plus minus 5 square. We get 65 by 13, whose value is 5. 5. Find the points on the x-axis whose distances from the line. These are 4 units. We have to find out points on the x-axis whose distances from this line are 4 units. Let us roughly draw. If it is 3, it is 4. This is origin, this is x-axis, this is positive direction of y-axis, this is the line, AB is the line. We have to find out points on x-axis, whose distances from this line should be 4 units. It is 4 units. If it is 4 units, here we can draw a line whose length is 4. Here also we can draw a line which is also 4. Let alpha 0. Let alpha. We have to find out this point. Suppose this is P. and this is Q. The x coordinates of this point will be 0. It may be suppose it's alpha. For this also 0, this is also alpha. Let alpha 0 be the point on the x-axis, which is 4 units from this line. Therefore, by using perpendicular distance formula, we get this divided by this equal to 4. Simplify, we get this. Modulus of alpha minus 3 is 5. This gives plus minus of alpha minus 3 is 5. If we take plus, we get this. If we take minus, we get this. Solve alpha, we get two values of alpha. One is 8, other one is minus 2. Therefore, the points are 8, 0. Points are 8, 0, minus 2, 0. 6. Find the distance between the parallel lines. We have to find out distance between these two parallel lines for Roman number 1. For parallel lines, how to find is distance between the two parallel lines. Suppose it is line 1, it is line 2. Take an arbitrary point from the line 1, there is P, and draw perpendicular. Find its perpendicular distance from the line 2. That is the distance between the two parallel lines. Distance between two parallel lines is distance of a point from one of the line to the other line. These two lines are parallel as 15 by 15, 8 by 8 did to us. Their slopes are equal. Let us take a point from line 1. Line 1, that is, put x equal to 0, y is 34 by 8. Therefore, the distance between parallel lines is distance of the point 0, 34 by 8 from line 2. That is, replace x by 0, y by 34 by 8, y by 34 by 8, or 17 by 4, and plus 31, whose modulus whole divided by 15 square plus 8 square, which gives 17, whose value is 65. 65 by 17 units. For Roman number 2, the two lines are parallel, that is the x and y, whose coefficients are proportional. Let us take the point 0 RL from second line. Put x equal to 0 and solve y, that is R by L. The distance between the two parallel lines is distance of the point 0 R by L from first line. That is, put first line x equal to 0, y equal to R by N, taking whose modulus whole divided by L square plus L square, which is root 2 times of L R by P. This is the required distance. Question number 7. Find the equation of the line parallel to the line D and passing to the point D. Apiba line asiga parallel oiba apiba point asi power line equation putu. The line of the equation of the given line is this, from which we have to solve y. We get y equal to 3 by 4 x plus half. The slope of this line, that is m, is 3 by 4. The coefficient of x. The equation of the line passing to the point minus 2, 3, with slope 3 by 4 is y minus y1 is 3. Slope is 3 by 4 times of x plus 2. Solving, we get thrice x minus 4y plus 18 equal to 0. Question number 8. Find equation of the line perpendicular to the line D and having x-intercept 3. We have to find out equation of line perpendicular to the given line and having x-intercept 3. The given line is this, from which we have to solve y in terms of x, which gives the slope of this line, that is m equal to 1 by 7. Therefore, the slope of the required line is minus 1 divided by m, that is 1 by 7, gives minus 7. If the required line makes x-intercepts 3, then the line passes through the point 3, 0. Therefore, the required equation of the line is the equation of the line passing through 3, 0, having slope minus 7, that is this. Simplify and put this 7x plus y minus 21 equals 0 is the required line. 9. The angles between the line this and this. Find the angles between the line this and this. We have to find out angles between these two intersecting lines. Here this. Solve y. Y equal to minus root over 3x plus 1, and from which y equal to minus 1 by root 3x plus 1 by root 3. Slope of first line is minus root 3. Slope of second line is denoted by m2, whose value is minus 1 by root 3. Using tan theta equal to this, we get tan theta equal to, put m2 and m1 their values here, we get this plus minus 1 by root 3, which gives, when tan theta is plus 1 by root 3, tan of 30 gives this, and another one is tan of 150. Therefore, theta equal to 30 degree or 150 degree, which are the required angles between the two intersecting lines. 10. The line through the points I3 and 4, 1 intersects the line this at right angles. Find the value of I. The line joining these 2 points intersects the given line at right angles. Find the value of I. The slope of the line passing I3 and 4, 1 equal to y2 minus y1 divided by x2 minus x1. Using that formula, we get whose value is 2 by I minus 4. The second line is this, from which we have to solve its slope, that is 7 by 9. The two lines are perpendicular, therefore product of their slope must be minus 1, from which we get I is equal to 2 by 9. 11. Prove that the line through the points x1, y1 and parallel to the line ax plus by plus c equals 0 is a times of x minus x1 plus b times of y minus y1 equal to 0. The equation of the given line is this, implies by equal to minus ax minus c and y equal to minus a by b times of x minus c by b. The slope of the required line is minus a by b, as the two lines are parallel. The equation of the line passing through the point x1, y1 with slope minus a by b is y minus y1 equal to minus a by b times of x minus x1. Cross multiply and transfer, we get this. Hence proof. Two lines passing through the point 2, 3 intersects each other at an angle of 60 degree. Two lines passing through this 2, 3 pass, they make angle 60 degree. If the slope of one line is 2, if the slope of one line is 2, another slope is what? Find the equation of the other line. The equation of the line passing 2, 3 and having slope 2 is y minus 3 times equal to 2 times of x minus 2 implies y equal to twice x minus 1. The equation of other line passing 2, 3 and making 30 degree with the above line is y minus 3 equal to m times of x minus 2. Y equal to m times of x minus 2 plus 3. Using tan theta equal to modulus of m2 minus m1 divided by 1 plus m1 m2, we get tan 60 equal to m2 is replaced m1 is replaced by 2, we get this. Solving, we get two values of m. First one is this, second one is this. The equations of the lines are y equal to, put m equal to this for first line, and cross multiply and transfer, we get this. Or for second line, when m is put another value, we get this. Cross multiply, transfer and put a standard form, which are the required lines. Find the equation of the right bisector of the line segment joining the points 3, 4 and minus 1, 2. Right bisector. Suppose first point is A, it is B. Right bisector is a line which divide perpendicularly. Right bisector is this line. The slope of the line joining 3, 4 and minus 1, 2 is y2 minus y1 divided by x2 minus x1 gives this, and whose value is half. The midpoint of the line joining these 2 points is x plus x1, x1 plus x2 divided by 2 plus y1 plus y2 by 2 gives 1, 3. The slope of the required line is the two are perpendicular, therefore minus 1 divided by slope of the above line, that is, which gives minus 2. Slopes are known, points are known. Therefore, the required equation of the line is the line passing 1, 3 and having slope minus 2 is y minus 3 times of minus 2 equal to minus 2 times of x minus 1. We get this, which is the required equation of the line. 14. Find the coordinates of the foot of perpendicular from the point this to the line this. Suppose given line is this point, given line is this, given point is this. We have to find out its foot perpendicular. We have to find the given line is this, which is equation 1. Solving y equal to, we get this, the equation of the line perpendicular to this line and passing minus 1, 3 is y minus y1. Slope of the required line d minus 1 divided by slope of the above line, that is 3 by 4. X minus x1 is here minus 1. Minus 1 is plus 1. Cross multiply, we get equation 2. Solving equation 1 into by cross multiplication, we get x by this equal to minus y by this plus equal to 1 by this. This gives first member with the third member, we get x equal to this, and similarly second member equal to third member, we get y equal to this. Therefore, the foot of the perpendicular is this. Question number 15. The perpendicular from the origin to the line y equal to mx plus c meets it at the point minus 1, 2. Find the values of m and c. Origin dagi line asida singakpa perpendicular gi makhong adu minus 1, 2 oirabadi m amasung c gi value puto. Since the point minus 1, 2 lies on the line y equal to mx plus c, therefore 2 equal to the coordinates of this point will satisfy this equation. Y the 2 pixel c, x the minus 1 pixel c, we get this, which is equation 1. As in this picture, the perpendicular distance of the line this from origin is distance between this point and the distance between these 2 points. Applying distance formula for this, we get this, and which is perpendicular distance palagadi line asi the origin ki singakpa perpendicular distance formula palagadi, we get this. Squaring and using 1, we get a quadratic equation in m. Solving m equal to half. From equation 1, c equal to 2 plus m, that is 2 plus half, that is 5 by 2. Which are the required values. 16. If small p and small q are the length of the perpendiculars from the origin to the line this and this, respectively, prove that small p square plus 4q square equal to k square. We have small p using perpendicular distance formula. From origin to this line is this. Simplify, we get this. 4q is also perpendicular distance of the line from the origin. Similarly, we get this. Therefore, p square plus 4q square is, whose value is this, whose value is this. Simplify and taking out k square, we get k square times of cos square twice theta plus sin square twice theta, whose value is 1. That gives k square. Hence proof. 17. In the triangle ABC with vertices A2, 3, B4, minus 1 and C1, 2, find the equation and the length of altitude from the vertex A. The slope of BC is y2 minus y1 divided by x2 minus x1 gives minus 1. As in this picture, the slope of AD, which is perpendicular to BC, therefore minus 1 divided by slope of BC, that is minus 1, we get 1. Therefore, the equation of AD is a line passing through A, 2, 3, and whose slope is 1. Applying this, we get this. The equation of BC is y plus 1 equal to 2 plus 1 by 1 minus 4 times of x minus 4. Simplify and we get this. Therefore, length of altitude AD asidi distance formula palo point A dagi BC da singak perpendicular distance palo si phangi. 18. If small p is the length of the perpendicular from the origin to the line whose intercepts on the axis are a and b. Then show that 1 by p square equal to 1 by a square plus 1 by b square. Small p is the length of perpendicular from the origin to the line whose intercepts on the axis are a and b. This shows that the line b x by a plus y by b equal to 1. Therefore, P, which is the length of the perpendicular drawn from the origin to the above line, put x and y equal to 0 minus 1 transpose on the left hand side, taking modulus all divided by square root of coefficient of x, that is 1 by a whole square, plus coefficient of y, that is 1 by b whole square, and simplify, we get the result. Hence proof. Thank you for watching video.